Alright, so this over here represents what you got from the field, okay? So you went to the field, you surveyed your data. This is what you got. Now in the field, before we went to the field, I was explaining that you need to know how to book your backside, your interside, and your foresight, so that you can, and then also your remarks, so that you can be able to do the computations when you come back to the office, right? So now we are back at the office, and I've extended the table for the purpose of the computation. There are actually two ways of reducing your levels in order to determine your elevations above the mean sea level. We call it reduction of levels, okay? And there are two methods. The first one is the rise and fall method, and the other one is the HPC method. Now HPC represents the height of plane of collimation, alright? So this one, it's like when you have your instrument here, that straight line I've always been talking about, it's called the plane of collimation, or the line of collimation, alright? Collimation. Like this, it's called the line of collimation. And when it sweeps across, it's called the plane of collimation. So it's basically the same, thing. Alright, so I want to show you first the first method, then after that I'll show you how to use the second method to compute reduce your levels. They both depend on you for the sake of your convenience. However, the rise and fall is easier to use when you have lots of change points, okay? So you can see that we have a change point here, we have a change point here. So it's easier to use when you have lots of change points. But when you have just one change point, or just a few change points but lots of intersides, this is much easier to use, okay? You don't have to do it. The computation is less easier when you have when you use the HPC to compute a lot of intersides. I will explain that maybe in another video. Alright, so I'm just going to wipe this away, then we can begin to do the computation. It's pretty simple, especially if you have drawn your table correctly. So you can see that we have our backside, interside, foresight. Now I've added a few more columns. We have the rise, the fall, the initial reduced level. Because it's a table, I didn't want to make things clumsy. So IRL means that's the initial reduced level, and then the final RL, okay? So FR, okay, so let me just make it FRL, because the final reduced level. And then we have our remarks. Oh, I didn't state this one, adjustment. So this one here is like adjustment, okay, or correction. And don't worry, I'll be explaining each of these at the right time. But let me just quickly explain what the reduced level is, so that you can have a good picture. So remember I said that we have the sea level here, right? Oh, okay, it's supposed to be plain. So I said we have the sea level here, and we have our ground here. And so if there's a point here, let's say our first point, we took a point, let me put our instrument somewhere here. Alright, and this is our plane of collimation, right? So if this point has, let's call it benchmark 1, BM1, and BM1 has a height, in this case, I didn't indicate the height, I should indicate them from this. So BM1 has a height of 48 point, let's say 218. Now, this 48 is above the sea level. Do you understand? That's this height. Okay. However, with the level instrument, what we were able to obtain was, we obtained this other height, maybe 2.191. Okay. 2.191, like this. Now, what you're going to do is, in order to get your reduced level, you sum these two to get what you have, what we call the reduced level. So it will be what? Let me help. Let me get my plus 48.218. Okay, so it says we have 50.409 as the height of this plane above the datum. Okay, so in this case, this is what we call an HPC, even though we are not talking about HPCs right now. But this height is called a reduced level. If there were another height here, another point, what's the name? 0.2 here. This 0.2's height would have been this, which we don't know yet. Okay, we would have used this 50.409 to determine that height. I don't know if you got it. Alright, so basically the reduced level is the elevation. Okay, the reduced level is the elevation. So we could just call this one initial elevation, final elevation. You could do the same thing, but it's easier if you put the IRL and then the FRL to make your table less clumsy. Alright, so I'm just going to go ahead and start with the rise and fall method. Now, with the rise and fall method, all you have to do is find the difference between successive points. Okay, and remember how it goes. They started with a back side and ended on a forward side. So that makes this what's the name? That makes this, it's joined like this. Alright, so that makes it a line or a set of readings from a station. Then a new station starts this way and a new station starts this way. Alright, so let's deal with the first station. We'll find the difference between these two. So this one minus this one. Then we put the answer depending on what we get. Okay, so I'm just going to use my calculator and do that, and let's see what we get. So we have 2.191 minus 2.505. It gives us negative 0.314. Now, because it's a negative, we are going to put it in the fall column. Okay, because it's negative, it means that this point here is higher than this point. Okay, so I'm going to put that value in the fall column, 0.314. Now, if you are putting it in the fall column, you don't need to indicate the negative anymore. Okay, the fact that it's in the fall column means that there's a negative attached to it. If it were positive, we would have put it in the rise column. Now, let's proceed. So the reason why we're not doing this is because, first of all, there's no number preceding it. Okay, so this is left as dash dash. Just leave it as it is. So we do for these successive two also. And what do we get? So we have 2.505 minus 2.325. Okay, so this one minus this one, the answer we get goes to the side, alright? So, but we get a positive answer, 0.180, sorry. So we have 0.180 over here. It's positive, so we put it in the rise column. Then we do for the next successive values, 2.325 minus 2.325 minus 1.496. We have 0.829 and it's positive, so we're going to put it over here, 0.829, like this. Alright, then we proceed. We have which one again? Alright, so this line is done. So we come here, take these two, find their difference. Okay, so in the same way, 3.019 minus 2.513. So 3.019 minus 2.513, the answer we get is positive, and we will put it in the rise column. Okay, so 0.506, like this. Alright, almost done. So we find between these two also. So 2.513 minus 2.811. And this time we get a negative answer, so we put it in the 4 columns. Okay, so 0.298. 298. Alright, just load one more. So you see that this one also ended on the foresight. Starting back with the backside again, we move to another foresight. So just load this line. So this line is, there are no intersides on this line. So 1.752. So 1.752 minus 3.824, and we get a 4 this time, negative 2.072, right? Yeah, so I put it here, 2.072, that's a 4. Alright, so now that we are done with our rise and fall columns, now I've updated the remarks column. This side is usually filled in whilst you're at the site. Okay, so the benchmark you started with, you identify the name of the benchmark and its height. Then the rest of the points, if they have labels, you can add their labels. Sometimes they don't. And then finally, the benchmark you ended with, you identify its name and add its height. Okay. So basically that's it. I just had to update it because I didn't add it in the first time whilst I was writing the data. Alright, so now what we have to do now is we will compute our initial elevations or our initial reduced levels. And how do we do that? Because this one is on a benchmark, the backside started on the benchmark, you can see that it was read on the benchmark. It means that we already have an elevation for that one, 49.873. 49.873. So we have an elevation for it or an initial reduced level for it, right? Actually, that particular benchmark, we already know its height, so we don't need to compute it. We are only using it as a reference. So with this one here, we will compute for this one and this one and this one and this one and this one. That's for QRSTU. And remember, on the fall column, it means it's a negative value. On the rise column, it's a positive value. So we are going to take this one and add it to this, and then the answer to this, and then the answer to this, and then the answer to this. See? So it's basically, so let's do that. So 49.873 plus minus 0.314. Okay. If I should do it here, 49.873 plus minus 0.314. So just the same as saying minus. That would be 49.559. 49.559. Okay, so it's just like saying 49.873 minus 0.314. So with this 49.559 plus 0.180 because it's on the rise column. Okay, so plus 0.180, we get 49.739. Okay, so 49.739 like this. And then the next one is also right, so plus 0.829. So plus 0.829. What do we get? We get 50.568 like this. And then the next value is also a rise, 0.5. So I add 0.506 to 50 points. It's going to give us 51.074. 51.074 like this. Alright, so 51.074 minus, because it's in the 4 column, so 51.074 minus 0.298, we get 50.776 like this. 50.7. Alright, so and then the last one would be 50.776 minus 2.072, so minus 2.072, and we get 48.704. Alright, so that's basically the initial reduced level. Now, this is where the second benchmark comes in. Now, ideally, you would have been done. Ideally, your computation is over. But when you look at what you're supposed to get for this benchmark, where is it? Benchmark 2. You were supposed to have a height of 48.710. But then you had 48.704. That's where the second benchmark plays a role. So you realize that there's a discrepancy somewhere. There's an error, right? This was what you were expecting to get, but this was what you observed. So we will try and compute our error. Let me call it total error for the survey. Okay. So the total error for the survey is our observed minus expected value. Okay, so you would see that over here our observed is what? 48.704 minus what you were expecting to get, 48.710. Okay, so let's find the difference. I think it's 0.006, right? Minus 48.710. Yeah, so our error is, or our total error is, let me put a T here to represent total error, negative 0.006. Alright, negative 0.006. The error is in meters because that's the unit of your level staff. Okay, so all these values are taken in meters because that's the unit your level staff was measured in. Okay, so this is the total error, which means that the whole of the survey, you made this kind of error. Now, there's another aspect of surveying that tells you if your work is correct or not, okay, or if it's acceptable or not. So with an error of 0.006, we need to check to see, can we proceed with this according to standards? Is it acceptable? There is a way to do it, and it's called, I think I'm just going to push this value aside somewhere here. So total error, I want to put it somewhere here. Total error equals to negative 0.006 so that I can wipe the board. Alright. I think I'm going to use a black marker now. Alright. So with this total error, I'm going to check to see if it's allowable. Okay. Old marker. So I'm just going to check to see if my work is allowable. Okay. So I'm going to do something like this. It has a formula k square root of n. Okay. Now this k is a constant. In general surveys, we use a k of either 5 or 3. So let's use 5, right? And then the root n. N is the number of stations, where n equals the number of stations. And how do you determine the number of stations? Simply count the number of back sides you have or the number of inter sides you have. They should give you the same values, alright? So 5 root n is what? 5 root 3. 5 root 3 is about 12 millimeters. So it's in millimeters. This, what's the name? Just in millimeters because the constant is in millimeters, okay? And then the units, this one is the number of stations. I hope I've already explained it here. Alright, so with this, you compare what you have here, your allowable misclose to your total misclose or your total error. If you see that your allowable error is huge than your total error, then it means your work is good enough to proceed. So considering this, it's a plus or minus, right? Plus or minus. So considering these two, you realize that your total error falls within an allowable error. So it means that you can proceed with your survey or with your computations. Alright, so we want to adjust these initial heights so that they fit in properly and end up getting this particular height we're looking out for. So with this total error of negative 0.006, it means that our error per station is the total error over number of stations, right? Which means negative 0.006 over 3. This should give us negative 0.002 meters, okay? So this is the error we made at each station, or at the first station, assuming. Now, if this is the error, then the correction or the adjustment or correction would be the reverse. So in this case, you can see that our error is a negative, right? So our adjustment is going to be a positive 0.002 meters. So that's the correction we make at the first station. And for leveling, we say that the error is cumulative, which means that if I made an error here at this first station, okay, if I made an error at this first station, an error of negative 0.002 at this station, the station where I read all these points, when I move to this next station, that 0.002 is cumulated, which means that it is multiplied by 2, or by the next station's number. So let me just explain that. Over here, we made an error of we have a correction of 0.002. Okay, good. Now, because this one has no error, because it's the same benchmark, it's a benchmark, it's fine. Because this 1, 2, 3, 4 were read from the same station, it means that they all have the same error, like this, 0.002, 0.002, okay? But then we have a new station here starting from this place. 1, 2, 3. They have incurred a new kind of error. So for those ones, what we are going to do is we are going to multiply our correction by so this is benchmark 1, station 1, this is station 2, so we'll multiply our error by 2. Anyway, it's not necessary. So I'm just going to multiply our error by 2, and we'll have 0.004 over here. Okay, because we have a new station we are working with, and 0.004. However, at this stage we have a new station, or a new set of values. Okay, so for this new set of values, we multiply the same 0.002 by 3, because that's the third station, which means the error is cumulative by 3. So if you multiply 3 by 0.002, you get 0.006. Right? So I want you to understand that. I'm just going to wipe this and then probably re-explain that again for you. So we have our error per station as, let's call it adjustment. Okay, adjustment per station. Adjustment was 0.002 positive. Okay, so this adjustment is for the first station. So this is for station 1. Alright, and I'm saying at station 2, we make a cumulative error, which means that we multiply that error by 2. That's the correction we have. So in order to fix that error, we multiply it by 2. It's just like saying at every change point, multiply by that factor. Okay, so over here we get 0.004. And then at station 3, this was station 2. At station 3, we multiply by 3, and that gives us 0.006. That's how come we have these values here. So 1, 2, 3 belong to the station. Alright? And then 1, 2 belongs to the station, and then 1 belongs to the station. Take your time and study it. I'm sure you understand what I'm trying to explain. Alright, so that's just it. So now we continue with our table. It's actually not a long process, it's just because I'm taking my time to explain every step. That's how come it looks long. So now that we are done filling our correction column, we are going to compute our final reduced level. Now, because it's a benchmark, because the first one is a benchmark, we don't need to correct it. It's already correct. Okay, so we just repeat that same value here, 49.873. Alright? However, at these points where there are corrections, you just sum them. Okay, so this plus this will give you the correction you need. Okay, so we would have what? We have 49.561, huh? 560, I think. Let me just do that. 0.002 plus 49.559. 561. Alright. Oh, 561. Good. 561. 49.561. Good. And so you sum the next one too. You would have what? 49.741. I think. Just confirm that. 0.002 plus 49.739. Yeah, 49.741. That's correct. So the same thing. So 50. I'm summing these two. Okay. So 50.570 because it's 8.2. And then at this stage we add 4.004 to it, so we would have 51.078 because I'm adding this 0.4 to this 0.4. And then the same for this one, 50.770. Oh, so that would be 780. And then at this stage, this time we're adding 0.006 to it, so that would be 48.710. Alright, so you can see that this one and this one are finally correlating, right? So your table is complete. Basically, that's how you compute that's how you reduce levels using the rise and fall method. Now I'm going to show you some few more things you need to do in order to before you can submit your table for cross-checking or for someone to sign on it. First of all, you do what we call arithmetic checks. Okay. Just to show that what you've done is actually in fact correct. It's just to indicate that you've done it properly. Okay, so there are a few formulae we use. All these back sides minus the sum of all the four sides equals to last reduced level, last IRL minus first IRL. Like this. That's one arithmetic check. There's another one. So the first one, we sum all these ones. So I'm just going to sum this one plus this one plus this one. And what do we get? Let me do that here. So 2.191 plus 3.019 plus 1.752, and so at this point we get 6.962, right? And then minus. Now I'm going to go ahead and sum all the four sides. So we have 1.496 plus 2.811 plus 3.824, 8.131, and that should be the same as the last IRL. Last IRL is 48.704 minus the first IRL, 49.741. 873. So so over here we have minus 1.169, and over here we have also minus 1.169. If you sum them, they should tally. All right. So this is one arithmetic check that can show that you've done it properly. Okay, you've computed the initial, you've computed up to this level properly. Okay, and the rest is just the adjustment. All right. So that's how you do the rise and fall method. Use the rise and fall method in order to compute your reduced levels for your leveling data.